Okay. Morning, everybody.
Morning.
Morning, Zach.
Morning.
Anybody
Morning.
get arrested last night? This weekend? Nobody got arrested? M.
Not
Daddy?
yet.
Will?
I don't think so. I don't remember.
You don't remember?
Wait.
What'd you guys do this weekend? Anything fun?
Work.
Yep.
Worked?
Work.
Well, that sucks.
Turned a treehouse into a goat playpen.
Turned a tree house into a goat playpen? Is that what you said?
Yes.
What you mean, goat or sheep? I thought he was
I
a sheep.
have goats too. They're the miniature ones.
Gotcha.
Goats are just as fun as sheep, Carter. So what do you harvest off the sheep? You use the sheep for the wool and the goats for the milk?
Honestly, we use the sheep to show. There's fairs to show them at. And for the goats, we randomly got a goat because someone wanted to get rid of theirs. And people just kept giving us goats. We breed them. We can sell them to the sale barn for $300.
Dang.
And they become full grown in about 6 months.
Anybody have any trouble with the homework?
No.
Nope.
Shall we go over it? What was
I
today?
forgot about the homework and did it in the last 20 minutes.
I have a question on one of the problems.
And what would that be?
Question 15 on solenoids.
All right, let's go over the whole thing and then when we get to that question, you can say, hey, I have a question about that one. Sound good?
Sure.
Okay, true or false? Push button assembly can have multiple contact sets.
True.
True or false? Emergency stop push buttons must be of the maintained contact type.
True.
True. You notice in your labs, your stop push button is not maintained, correct? So technically, can we associate that with an e-stop?
No.
No. Do you guys know what it means by the maintained kind? Have you ever seen a stop button? It's like push and you have to twist it to pull it back out. You ever seen that?
Yes.
Yeah. Limit switches are usually actuated by hand.
False.
False. How are they actuated?
It's like contact.
Yeah,
Okay.
something mechanically actuates them. So like in our garage door exercise, right? We simulated a garage door. And we actually had to, by hand, hit the limit switch. But real life is something travels somewhere, somehow, some way on a conveyor or a garage door or something has to trip that, not a person. True or false? Never actually operate a motor with a proximity sensor.
True.
Why do you think that is?
The large load going through the switch contacts.
Right. Proximity switches are kind of delicate little electronic devices that aren't meant to handle a bunch of load. So you wouldn't put that in series with the windings of a motor, because a motor is going to draw a lot of current. So how would you use a proc switch to actuate a motor? Turn it on or off?
Connect it to the coil starter.
With a motor starter, any high load. So a proximity switch, if you were using a proc switch to turn on a bunch of lights, if you had a bunch of lights in a room that was drawing several amps of current, you could use a control relay or a contactor, right? Because the load of a coil is very, very small. How could we figure out what the inductive, or I almost gave you, how could we figure out what the amperage of a coil for a motor starter would be? Well, one, we could just measure the current, and two, we can figure out the inductive reactance. Remember when you guys had to learn all that jazz? eBay's not to inductive reactance yet. I think he's the only one who hasn't finished 133. But anyway, there's a reason we learn all that inductive reactance, capacitive reactance, all that math. Never directly operate it. Oh, we just did that. True. Don't do it. Which of the following would be classified as a pilot control device?
A pressure switch.
Pressure switch.
Hey, Zach.
What?
This question.
Mm-hmm.
So pilot control device like such as relay, it could be a pilot control device, right? Relay.
A relay is not classified as a pilot control device because a pressure switch is actuated. It's I can't think of a better word than actuated, but it's I don't know what to say, but like it's an input. Let me see if I can find it in the book.
Okay. So my understanding was like relay or like switch contact as a kind of pilot control device, like motor contactor, starter, or controller is a primary control device. Just I understand that way. That's could be my misunderstanding.
Primary versus pilot.
Yeah.
Manually operated switches, primary control devices, component, blah, blah, blah. Primary control device, such as a motor, contactor, starter, or controller, connects the load to the line. A pilot control device, such as a relay or switch contact, is used to activate the primary control device. Okay, so here's the example I would give you. Okay, in this in this ladder diagram on the left, what is a primary control device that's on here? Not a pilot. What is a primary control device?
Your motor starter coil.
The motor starter. So if this is motor starter 1 and it's controlling motor 1, this would be our primary control device. How do we, like in the text, in the text it said primary control device, which is a motor, blah, 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 connects the load to the line. Okay. So how are we connecting the load? What is the load?
The motor.
Motor. So here's the motor. Here's your 3-phase 208 volt motor. And what is the line? What does that mean?
The power source.
Exactly. So here's your line coming in. Remember all this stuff down here, this is all just bells and whistles. What we're trying to do is just turn this motor on and off. So motor starter 1, this guy is going to connect the load to the line. How so? How do we energize the motor? By closing these. When we close those on here, remember those contacts represent this and this. Okay, coming through, these are the overload heaters. But when those close, when this energizes and those connect, the motor spins. So that's how we connect the load to the line. It's through our motor starter. So here's your primary control device. What is this guy?
It has the same drawing as the limit switch, but it says proximity maybe. So
Yeah,
like a
it's a proximity switch, a proximity sensor. So its whole job is to close if it's a normally open prox sensor. It's just like a limit switch. You can make them or you can use them as normally closed or normally open. Most of them, well, I won't even go there, but it's kind of like a limit switch. So this is a pilot control device because what is it doing? It's energizing the coil of your primary control device. And this one happens to be motor starter 2. So let's just say that this is our motor starter 2. Okay. A pilot control device is something that's going to actuate the primary control device. Okay. So your prox switch isn't actually connecting the line to the load. It's actuating the thing that is connecting the line to the load. Right. So is CR1 in this case. This thing will actuate the primary control device. So control relay 1 is a pilot control device, right?
Yes.
So 2 things have to happen for this motor to turn on. This thing needs to close, which is a proximity switch, and this thing needs to close, which is control relay 1, coil, right? So those are 2 pilot devices controlling the primary control device. Does that make more sense?
Yes.
The type of switch shown.
Single pole, double throw.
Single pole, double throw. What kind of push button makes a circuit when it's pressed and returns to the open position when the button is released?
Normally open.
Normally open. Which of the following would be classified as a mechanically operated switch?
Limit switch.
Limit switch. All these other types of switches are actuated by a human being. They're not mechanically operated. A limit switch is actuated by something non-human touching it, hitting it. When a metal object enters the high frequency field of an inductive proximity sensor, what does it cause?
A decrease of energy in the oscillator.
Yes. Which of the following sensors is designed to sense the strength of a magnetic field?
Hall effect.
Hall effect sensor. Which of the following converts rotational speed into an analog voltage signal?
Tachometer.
Tach. Which of the flow meters operates by measuring changes of induced voltage of conductive fluid?
Magnetic.
Magnetic. The type of relay contact arrangement shown is what?
Single throw.
Double pole, single throw. What does this dotted line going through this mean?
Is there mechanically connected?
Yes, if you see a dotted line on a print anywhere, that means it's mechanically connected. So you can't close one without closing the other one. The coil current for AC solenoids is primarily limited by the what of the coil?
Inductive reactance.
Boom. Now you're like, all right, I understand why I memorized all that math stuff. But think about it, it is kind of important, right? I mean, whoa. If you take just this line right here, forget about everything else. 120 volts going through the motor starter 1 coil. So this coil, all this is a wire that's wrapped round and 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 comes back out. So here's one end of the wire, here's the other end of the wire. If I put 120 volts on this wire, right there and right there, what would happen to that circuit? I put 120 volts on it, what would happen to it? What would the current be like? Astronomically high, right? Getting a lot of confused faces. Take this example and take this conveyor coil out. So this is just a straight line. This is the wire that I'm holding in my hand, okay? Coming from the transformer, we're going through the fuse. Change colors. Going through the fuse. Do, 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 do. And then I push this button down. So this closes. And my current's going do 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 do. All good? Nothing's gonna happen or burn up?
Yeah, could be equivalent of a short circuit.
Basically, there's nothing resisting current flow. So E equals I times R. So I equals E over R. If this is 120 volts, what do you think the resistance of it is of this circuit?
Pretty low.
Pretty low. Let's say it's 1 ohm. It's probably not even that. So what's 120 divided by 1?
120.
120 amps. Right? Pretty high. Think this little fuse 9 is going to hold that?
Nope.
No. Do you think this tiny little wire is rated to hold 120 amps?
Nope.
Nope. Going to burn right up. Kind of crazy, isn't it? So, okay, now instead of that straight line, we put this coil in here. So I'm going to take this wire and just wrap it around, round, 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 round. Oh, now I've made a coil out of it. And now it has enough resistance in an AC circuit that it'll be low, like maybe less than an amp. Pretty crazy, right? That's why we learn about inductive reactance. The amount of pulling or pushing force produced by a solenoid is determined by blank.
That was my question problem.
Your problem question?
Yes. It'd be B, number of turns in a coil.
No, it's both of them.
It is.
Number of turns in a coil and the amount of current through the coil, both of those will affect the magnetic field, right?
Mm.
So if you think about an inductor, if I have more, whoops. So I'm creating a magnetic field here. Is this going to be a very strong one? If I put 120 volts on it? No,
No.
because there's only 3 turns. If I add more turns, so I made this longer and turned and turned and turned and turned more, it's going to create a stronger magnetic field. If I increase the current through it, that is also going to increase the magnetic field. Okay? Does that answer your question or no?
Yes.
Solenoid valves are able to control what kind of flow?
All of them.
All of them. What kind of solenoid valve blocks flow when the solenoid is de-energized and allows flow when the solenoid is energized?
Normally
Normally.
closed.
Normally closed, kind of like a limit switch, right? For a DC stepper motor, the amount of rotation is directly proportional
Number of pulses.
to the number of pulses. What kind of switches are small assemblies designed for mounting on printed circuit boards?
DIP.
A dip switch. Float switch is used to sense the height of the liquid.
Yep.
Drum switches are used for starting and
Reversing.
reversing the motor. An actuator is any device that converts an electrical signal into what kind of movement?
Mechanical.
Mechanical. All good? Okie dokie. Lab 8. Nothing new here. We're just going to use IEC relay and an ice cube relay. Do you remember me telling you what the difference is between IEC and NEMA?
The ladder diagram on ICA is a vertical, NEMA is a horizontal.
Can you say that again, eBay?
The ladder diagram,
Yeah.
vertical and horizontal.
No, IEC versus NEMA. I'll show you. Still with me?
Yes.
Farewell and adieu to you fair Spanish ladies. Farewell and adieu to you ladies of Spain. For we've received orders from the sail back to Boston. Anybody know that song?
Nope.
First time I heard it.
It was beautiful, though, Zach.
Thank you. Oh, who said that? Oh, you're my favorite.
Sweet.
Okay. NEMA, IEC. Now there's all sorts of different components that are, I mean, basically everything that you could think of that are on these ladder diagrams that are at least pilot and primary control devices are going to be either NEMA or IEC. NEMA stands for National Electrical Manufacturers Association. And they are my favorite things to work with because remember when I took this thing apart? Remember that? Remember that day we had so much fun, guys?
Yes.
Remember that?
Mm-hmm.
Most fun ever.
If this thing's coil goes bad, I can take this thing apart and replace the coil, right? If this thing's normally closed contact right here goes bad, I can take this thing apart and replace it. This is IEC. IEC stuff is generally lighter. It's generally plastic molded cased stuff. It's generally a little bit more convenient to use. So like on the back of these, this is a slot that's for mounting this on what's called DIN rail. And in a minute, remind me and I'll show you what that is because it's on the trainer behind me. But DIN rail is just a type of aluminum or steel rail that mounts kind of like that. And this thing just snaps on there. So you could have all sorts of IEC relays and timers and stuff mounted in the back of a cabinet that just click. And then how you take that off is this little tab right here that pushes. When you pull this, it pulls up, and that's how you snap this on and off of DIN rail. But do these two things do exactly the same thing?
Yes.
Yep. Here's the coil for this. It's a 120 volt coil. Here's the coil for this one. This one has two normally closed contacts. These two are normally closed, and these two are normally open. On here, I have normally open, normally closed, normally open. So this is one set. This is another set. It's the exact same thing. When this coil energizes, you'll see this thing suck in. Remember that? When this thing's coil energized, you'll see this push in. Bloop. Same exact thing. These are a little bit more robust and durable. But if you notice that, what if this coil goes bad?
You might not be able to replace like a contact.
Yeah, you know, I've never tried to open one of these things up, but I don't know if it's doable or not. I'm not sure about the coil, but what if this contact goes bad? Can I replace just that one contact? Nope, you have to throw the whole thing in the garbage. So is it likely that that contact will go bad? No, but I've seen it happen. And you could just replace the one contact in here. What else?
One more efficient.
Are they more efficient?
It's repairable.
Yeah, I guess you could say in that regard that it's more efficient. These are more robust. These are built to take abuse. These ones, not so much. They are typically cheaper. IEC components are typically cheaper than NEMA for those two reasons. They're molded case, easier to manufacture, so that makes them cheaper, but they're also not as robust. And you can't do as much with them. But they're exactly the same thing. So really, a lot of times it comes down to just preference, you know. But that's the difference. IEC and NEMA. All right. The other thing new on this lab is you're going to use something called an ice cube relay. There's one. There's one. There's another one, but this kind of sucks, so I'm not going to show you that one. Here's another one. Why do you think they're called ice cube relays?
Because they look like ice cubes.
Because they look like freaking ice cubes. I love these things because you actually get to see them, see the guts of them operate. Like when this thing actuates, you can't actually see those contacts inside of there make and break. On these ones, you can. Let me, I'm actually going to switch cameras here so I can do some zooming. All right. I guess I'll start with this one since this is the one that most of you will have these on your trainer. Now, I don't care if you have more than one different type. I don't care which one you use. I'll start with this one. Okay, so here's how all ice cube relays are going to have the relay itself, and then they're going to have a socket. Okay, so this is the relay and this is the socket. Now, how this works is see a coil in there?
Yep.
I do too. So if you think about it, these are actually what plugs into the socket. Okay, these little pins here. So which pins do you think are associated with the coil?
The ones directly below the coil.
Yeah, if you look very closely, it's this guy right here. You see how that pin, this guy, is soldered to the inside one, and then there's a little wire that goes down and into the coil. And then that wire wraps around and around and around and around and around. And on the other side comes back out right here. So these two pins are associated with the coil. Which two pins? This one happens to have 3 sets of contacts. So where this guy had 4 sets of contacts, abnormally open, normally closed, normally open, normally open, normally closed, whatever. You see what I'm saying? There's 4 sets there. And this, there's 4 sets. This one has 3. This is 1 set, 1, 2, 3, 1, 2, 3, 1, 2, 3. If you look inside of there, you can see how that works. So this pin here is going to be common to the other 2. If you look on the inside, it's soldered to this little wire that comes up and around to here. And this is a common point. There's this little plunger that right now is sitting against this one. So do you think this pin and this pin are normally closed or normally open?
Normally closed.
Normally closed. This pin with this pin is normally open. So what happens is when this coil gets energized, it creates a magnetic field, pulls this in, and you'll see that little flapper go down and make contact with here. So this and this pin are closed. When the coil energizes, this opens, and this one closes up with this pin, right? So if I put 120 volts on this pin, and let's say the top one I had a green light and the bottom one I had a red light, would the green one be on right now?
No, the red one. If you
If this is green and this is red, and I put 120 down here, the top one would be on, right? So the green one would be on. If I energize the coil, the green one would turn off and the red one would turn on. Make sense?
yes.
All right. So that's the type of relay that you have on your trainer. Now that you've seen how the guts of them work, if you look on the socket on the side, so this is where that thing stabs in. Remember the bottom 2 are the coil, and then you have 3 sets of contacts in there, and this thing stabs in. I'll go ahead and put that in there. Bloop. So it just pushes in, and it's got these little tabs on there to keep it from falling out. All right, then if you look at the side of this thing, it's got a diagram of the same thing that I just showed you. So on this diagram, which 2 screws or pins do you think are the coil?
13 and 14.
13 and 14 are the coil.
Is there numbers to know which screw is which?
That's what I'm looking for. Usually there are, but I'm not seeing any on here. So the ones on your trainers may or may not be labeled. But just looking at this, which two would you say are 13 and 14? So look at your screws and then look at this. Which ones do you think are 13 and 14?
Those bottom two.
Yep, so these are your coil. If I was going to use one normally open set of contacts, which ones would I use? I have three different options.
Oh, would it be 4, 5, and 6?
Nope. They go vertically, okay? So 7, 8, and 9 are the commons. If you follow 7 up, it's this middle point here. So that's common to the other two. 4 makes up here, and 1 makes up to this. So when the coil energizes, this changes state. And this opens and goes down here.
So it's 7, 8, 9.
What?
So it's 7, 8, and 9 for your question.
7, 8, and 9 are the commons. Okay, so no. 1,
9 and
4, and 7 is a set of contacts. Okay, so if I'm gonna magnify this and just draw it. So this little flapper here, if you trace these lines down, this is 7, this is 4, and this is 1. Can you see that? 1's at the top, 4's at the bottom, and 7 is the common. So 7 is common to the other two. Right now, 7 and 1 are closed. When I energize the coil, when I energize that, this changes state and it becomes this. Right? So this is de-energized coil. This is energized coil. And do you see how 7 is common to the other two?
Yes.
All right. Anyway, that's how you read the drawing. Now, if I didn't want to use that one, I could use 9, 6, and 3, right? So 9 and 6 would be normally open. 9 and 3 would be normally closed. Follow?
Yes, sir.
Here's a couple different types of ice cube relays. This is another pretty common drawing that you'll see. And these ones are pretty cool because they've made this one clear so you can actually see the contacts make and break pretty easily. But right now, the common one is in the middle, and this is normally closed and this is normally open. If you read the drawing, which ones are the coil?
Be pin 7 and 2.
Pins 2 and 7. So here's your coil, you follow those lines up and you got 2 and 7. If I take this off the socket, these ones are labeled 2 and 7. Let's see if I can zoom in so you can see those numbers. Can you see the 2 and the 7? Kind of hard to see. Can you see them?
I can see them now. They're
2
up top.
and 7. Okay, so on this socket, if I wanted to use a normally open contact, which pins would I use?
21 and 6.
21 and 6.
Or is that 8 and 6? Can't tell which.
I'll direct your attention to part of this thing that looks like this. So here's a common. Here's normally closed. Here's normally open. So when the coil gets energized, this turns into this. Make sense? So this is what you see over here in this spot. Common, normally closed, normally open. When the coil energizes, this thing comes down and makes contact with the bottom one, and this one opens up. So if this is what is drawn on here, what would be my common here?
The 8.
Yep, follow that line all the way down, and 8 is the common. Associated with that common, you have a normally closed, which is pin 5 or 22. And normally open would be pin 6 or 24.
Why did they put both numbers on there? There are 2 numbers on the block itself.
No, I'm not sure why they have the 21, 24, blah, 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 blah. On the socket, the smaller numbers are what it uses. I'm wondering if maybe different sockets have different numbers on them, but this one happens to have 1 through 8. So if I was going to use a normally closed, if I was going to use this side for normally closed, I would use 8 and 20, 8 and 5. All right, so on the socket itself, that's 8 and 5. 8 and 5. And if I was going to use normally open, I would use 8 and 6. So it'd be 8 and 6. That'd be normally open. Cool.
Cool.
All right, here's another octal. So I not want to come out of there. By the way, these are called octal because there's 8 pins. Same deal, same concept. Everything works the same way. You got a coil, you got a couple different sets of contacts in there. And this is how it plugs in on the back. But this one's actually a little easier to read, I think. 2 and 7 are the coil. 2 and 7 are the coil. 1 and 4 would be normally closed. 1 and 3 would be normally open. 8 and 5 would be normally closed. 8 and 6 would be normally open. Make sense?
Yes.
All right. Should we go through and wire this thing up? You guys want to take a break?
No. Good.
Okay, what's the first thing we should do?
So is that rail with the relays on it? I think you were going to show us that.
Oh yeah,
That one.
this is DIN rail. Okay, so this is the same kind of relay that I just showed you. This is an IEC control relay. This is a NEMA control relay. This is these are the two basic types of ice cube relays that I just showed you. And all they do is just slap on to the rail there. And if I wanted to take them off, the tab down at the bottom, so pull it out with a screwdriver, and it just lifts off of there. So back here, this is the tab at the bottom that holds it into place, and it just cups over that rail. Put the top in first and then snap it on. And it slides around. That's DIN rail. What's the first thing I should do on my print before I start?
Number it out.
Number it up. One, 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 one. Right? Are those all ones?
Yes.
Yep.
Everything over here, are these twos?
Yep.
Two, 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 two. All right, to the right of the stop button, what is that?
Be 3.
Three, three. And over here, what is this?
4.
Four, 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 four. To the right of this control relay, normally open.
5.
To the right of start 2.
6.
To the right of control relay 2, normally open.
7.
Cool. Now the instructions for this lab say use an IEC relay for control relay 1 and an ice cube relay for control relay number 2. So this is going to be IEC. And this is going to be ice cube. That'd be too confusing if I just put IC, IEC and IC, IEC and ice cube. All right, so where should I start?
Wires off the start push button or the control relay 1 coil.
Yes, and I would recommend, some of you guys have been leaving the old wires on. I would start taking them off because some of you guys are getting, you know, if I use a limit switch in this lab and there's still a limit switch up here, but maybe this push button is still connected to that limit switch. When I energize my new lab, it might backfeed something from the old lab and we've been having problems. So I would recommend that you guys start taking all your old wiring off before you start a new one. If you're concerned with the cost of the wiring that we're throwing away, I appreciate it, but I would rather you guys not confuse yourselves in the labs.
Yeah,
Shall I
sure.
do that every time, Zach? Every time when I start a new lab, just take them, the old lab, just every time?
I would recommend it, yes. All right, what are we doing? I need a wire number 1 to go from the fuse of my transformer to a stop push button. Right?
Yep.
Will, it's time for you to start singing.
Ba ba.
Wait.
black.
All right. Done. Done. Let's finish up wire number 1. I also need to go to control relay 1 normally open. Control relay 1 is an IEC relay. So I will use this one. You got to be careful when you look at your control relay, you should have normally open and normally closed on there. But this one, for instance, has 4 normally open contacts. If I needed a normally open for this or normally closed for this lab, I could not use this one. That being said, wire number 1, I need to also go to a normally open. And on this one, all these are normally open. Well, all 4 of these are normally open, so I'm going to come right here. Do I have a control relay 1 normally closed? No, I do not. Okay. All right, good. All right, go ahead, Will.
Ba ba. Black sheep, have you any wool? No, sir. No, sir. 3 bags full. 1 for my master, 1 for my dame, 1 for the little boy living down the lane. Ba ba. Black sheep, have you any wool? No, sir. No, sir. 3 bags full.
That was beautiful.
No, no, sir. No, sir. Black sheep, have you any? 1 for my master. Ba ba. Black sheep. One for my master, 1 for.
Okay, pause that. Normally open CR1. Now I need to go with a number 1 to my control relay 2 normally open and my control relay 2 normally closed. Control relay 2 is my ice cube relay. So let me look real quick. My drawing. On my ice cube relay, what can I use for a normally open and what can I use for a normally closed? I have 3 different sets.
One would be 7 and 4. I'm gonna close 4 and 2.
No. 1, 4, and 7 are associated with each other, right? 7 is the common. 1 is normally closed and 4 is normally open. Do you see that? Remember this drawing? 7 and 1 are normally closed, and 7 and 4 are normally open,
Yes.
right? So I'm gonna go to 7 as the common. And I'll use 4 is normally open and 1 is normally closed. Does that make sense?
Yeah.
So if I take a wire number 1 and I land it on normally closed 7, that would take care of this and this, correct?
Yes.
Because on the other side of this, I'll use wire number 7 or pin number 7. On the other side of this, I'll use pin number 4. So when that coil energizes, this will close and this will open up. Make sense?
Yes, sir.
Yep.
For right now, though, all I need to do is take a wire number 1 to pin number 7 on here. That's the common between those other 2 points. And 7 is going to be this screw. So this is a wire number 1. I'm going to take that down to this screw right here. Well, that's done. Oh, couldn't see what I was doing, could you? That being said, if I wanted to, could I use another set of contacts that are on here?
Yes.
Instead of using the same set for both normally open and normally closed?
You could, but it would just use another wire, right?
Correct. You're taking up space on that relay that you don't need to. So what I'm trying to say is I could have taken a wire number 1 to here and to pin number 8, which is the middle one. But all I'm doing on this ladder diagram is energizing control relay 2, closing one set and opening another set. Right? So I can use this common. So this is wire number 1, and pin number 1 is normally closed and pin number 4 is normally open. I could have used 7 and 1 for normally closed, and I could have used 8 and 5 for normally open. I could have used 2 sets there, but I can do the same thing with one set of contacts over here. Okay, so my wire number 1s are done. Let's do wire number 3. Need to go from stop, the other side of my stop button, to the start. It's just going to be a little jumper wire. So the other side of my stop over to a start. So I have a start button here. That's already done. I also need to go to control relay 1, normally open. So that's my IEC relay. I've already used this normally open for something else, so I'm going to come over to another normally open. I'll just bring it all the way over here so you can see that they're different. And that's going to be wire number 3. So I'll come from my start right there where I just landed this 3, and I'll come over to this normally open contact. Sound like a winner?
Yep.
Yep. Can I get a, oh yeah?
Oh yeah.
Oh, you gotta crack me up. The 3s are done. Wire number 4, the other side of start 1. I need to go to 2 places on the control relay 1, and I need to go to the green light. So my start push button is right here, the other side of my start. And I need to go to the green light. And I need to go to control relay 1, which is the IEC relay. The coil, and also the other side of the normally open. It's my holding contact. Do that now. Can I get a oh yeah?
Oh yeah.
Yeah, now we're talking. I just went from the other side of the start to my green light. Now I'm going to go from my green light over to the normally open control relay 1, the other side of it. And I also need to go to my coil, which is right here. So I'm gonna make a jumper, goes around to my coil. It's A1. One thing I was gonna mention to you guys is that sometimes I see you guys coming in here and looking at my setup on here, which is all fine. And I encourage that if nothing else, but keep in mind that part of your final exam is you'll be given a ladder diagram to make up on your trainer. And you're not going to have mine to look at. You know what I'm saying? So if you want to come in here and look at this stuff, that's fine. Just make sure you understand why different wires are going to different places, and not just that you're just copying mine and seeing if it works. 10-4.
10-4. I usually just look at it so I can see where on the motor you put wires.
Yeah, there's nothing
Where
wrong
you
with that.
crisscross.
I encourage you. That's why I leave it set up in here, is that you can see and remind yourself where I put things and why I did. Just make sure you understand it. That's all I'm saying. Wire number 4, done. Wire number 5, control relay 1, which is my IEC. I need a wire number 5 that goes from there to start 2. So that's the other side of my normally open contact over here, because this is wire number 1. This will be wire number 5. I need to go to start 2, which is here. Wire number 5 is done. Ba-doop, ba-doop. Wire number 6, the other side of my start 2 to control relay 2. Which is my ice cube relay, the coil. On my coil, which one is, or on my ice cube relay, which one's the coil?
Bottom 2.
Bottom 2. And these
It's
are
like we can't see
13
the
and
numbers,
14.
but yeah, 13 and 14.
13 and 14 are down at the bottom. And on physically, they are the bottom 2 screws down here. So the other side of my start, my ice cube relay right here. Coil, and 13. Have you any wool? I don't know the rest of the.
No, sir, 3 bags full. One for my master, one for my dame, one for the little boy that lives down the lane. Ba ba, black sheep, have you any wool? No, sir, 3 bags full.
In my 19 years of life, I've never heard that song before.
You did when you were
I
one or
haven't either.
two. No, you did when you were 1 or 2. You just don't remember it because you're not as culturally colored as me and Will.
I have never heard my parents sing that to my brother or anything. So
Have
Yeah,
you
no.
heard of hot cross buns?
Yeah, I played it on recorder in 4th grade.
I played it on trombone.
Wire number 6 is done. All right, let's do wire number 7.
You won't up me, Will.
Hot cross buns.
Wait a minute. Wait till I start wiring up wire number 7. Where are we going with 7? Control relay 2, the ice cube, normally open. So
Yep.
normally open on the ice cube relay is pin number 4. And that's going to be this screw. I need to go to the yellow light right here. So that screw to the yellow light. All right, go ahead with the next song.
Hot cross buns, hot cross buns. 1 a penny, 2 a penny, 3 a penny. Hot cross buns.
That's it?
Yep. It teaches kids how to play 3 notes.
What are the 3 notes?
Hot, cross, and bones.
I bet one of them C.
Like do, re, mi, fa, sol, la, ti, do. Is it la, ti, and so? Wire number 7's done. Somebody pick a song for Will to sing for wire number 8. Wire number 8, the normally closed on CR2, ice cube relay. So that's going to be this back pin here. To the red light. Do you know Gangsta's Paradise by Coolio?
Not off the top of my head. I know the song.
I was gonna say,
DMX died the other day. How about a DMX song? Slipping? No?
Does he do the y'all gonna make me lose my mind? That
Yeah. Keep going.
one? Up in here.
Yeah.
Up in here.
Yeah.
I don't know any of the other lyrics.
Keep going.
I can look it up.
Y'all gonna make me go all out. Up in here. Up in here. Y'all gonna make me act a fool.
Want to tell me what this is all about?
As I walk through the valley of the shadow of death, I take a look at my life and realize it's the death. Cause I've been blasting and laughing so long that even my mama thinks that my mind is gone. But I ain't never crossed a man that didn't deserve it. He be treated like a punk, you know that's unheard of. You better watch how you're talking and where you're walking, or you and your homies might be lying to chalk. I really hate the joke, but I gotta look. As they croak, I see myself in the pistol smoke.
Fool. Thanks, Will. Okay. That's wire number 8. So we are done. We just have to go and look at our number 2s. So what's first? IEC relay. This one on the coil. I need a 2 to get back to my neutral bar. Been spending most of our lives living in the gangster's paradise. Been spending most of our lives living in the gangster's paradise. Power and the money, money and the power, minute after minute, hour after hour. Done. Green light, neutral. The green light, the red light, and the yellow light, all those neutrals are shared and they come back to here, so I can mark all those off. The ice cube relay neutral is going to be pin 14 down here, the other side of the coil. Right, chunder, need to get that back to the neutral bar. My 2's done.
Seems to be.
Yes, they are. So I am all done except my motor starter. I've got hooked up here, but it doesn't matter. Why doesn't it matter? We're not energizing the motor starter in this lab. Right? Right?
Right.
Right. So if you look at this diagram, what should happen when I press start push button number 1? This is going to close. This is going to energize. This is going to close. And this is going to close. So before I press start 2, or before I press start 1, would anything happen when I press start 2? No,
No.
because this is open. So nothing's going to happen until I energize CR1, which is the IEC relay. When I press this button, the green light should come on and control relay 1 should energize, closing this and this. At that point, when I press start 2, this will energize, closing this and opening this. When I turn the disconnect on, are any of the lights going to turn on right away?
Red.
The red. As soon as I turn that disconnect on, the red light's going to turn on right away because coming out of the transformer, it already has a current path, right?
Yes.
So I turn the disconnect on, the red light's going to turn on. I hit start 1, the green light will turn on. When I hit start 2, the yellow light will turn on and the red light will turn off. Make sense?
Yes.
Yes, sir.
Okay,
Yes.
here we go. Disconnect going on should mean that the red light turns on. Boom. I hit start 1. That must be start 2. I hit start 1. IEC relay energized. Green light came on and stayed on. Now when I hit start 2, the red light should turn off and the yellow light should turn on because this coil is going to energize and change the state of both of those contacts at the same time. Ready? Look at that.
Nice.
So that is lab 8. Start 1, start 2. 10-4.
Yes.
Should we call it a day?
Sounds good. Will we have a quiz on Wednesday as well?
No. I believe the quiz is going to be over. Chapters 4 and 5. So let me look. Right. So we won't have a quiz until chapter 4 was due today. Chapter 5 will be due next Monday. We won't have a quiz over chapters 4 and 5 until Wednesday, the 21st.
Okay.
Sound good?
Sounds good.
All right,
Thank
I'll
you.
see you in class on Wednesday and we'll discuss the next lab. And then you guys can get started on your stuff.
All right. Thank you.
All right, have a good day, guys.
You too.
Yeah.
Thanks.
You
Yeah.
too.
Good, eBay?
Yeah, good.
All right. I'll see you Wednesday.
Thank you, Zach.
All right, see ya.
Bye.